Have you ever been in the middle of investigating an incident with alerts piling up, teammates asking for update, and not enough time to make sense of everything? In security operation, the cost of a delay is real. Missed indicator, incomplete triage, and decision made without full context. This learning path is designed to help you turn that chaos into clarity by showing you how Microsoft Security Copilot and its embedded experience can accelerate investigations and improve the quality of your response. Hello and welcome. I'm glad you've joined us. I'm Jean-François Bilodeau, a Microsoft technical trainer. In this session, we'll cover Defend Against Cyber Threat with Microsoft Security Operations Platform. As part of Learning Path 2, let's get started with Microsoft Security Copilot. Here's the agenda for this learning path. We'll start with fundamentals of generative AI because that's the engine behind today's copilots. Next, we'll describe how Microsoft Security Copilot and what it is and why it matters. Then we'll explore the embedded experiences, where Copilot's capabilities show up directly inside Microsoft security products. Finally, we'll look at Security Copilot agents in Microsoft Defender, which helps automate and accelerate common SOC tasks. To use Security Copilot well, it helps to understand the fundamental of generative AI. Here we pivot into the basics, what generative AI is, the role of large language model, where Azure OpenAI fits, what Copilot means in practice, and how prompt engineering helps you get better results. In this module, we'll explore how large language model, often called LLMs, enable AI application and services to generate original content from natural language input. We'll also connect that idea to the emergence of AI-powered copilots, which are designed to assist humans with creative and analytical tasks. By the end of this module, you'll be able to describe what generative AI is, what large language models are, what Azure OpenAI is, what copilots are, and how to improve generative AI responses using prompt engineering. We'll treat each of these as building blocks, and then you'll see how they map directly to real security workflow later in the session. Let's start by separating two related ideas, AI and generative AI. AI imitates human behavior by using machine learning to interact with its environment and execute tasks without being explicitly told exactly what the output should be. Generative AI is a specific type of AI that creates original content. This is what powers many modern chat applications. Generative AI application takes natural language input and return responses in different formats. One common format is natural language generation. For example, you might ask, give me 3 ideas for a healthy breakfast, including peppers, and receive a clear written answer. Another format is image generation, where requests like create an image of an elephant eating a burger can result in a new image. A third format is code generation, where you might ask, show me how to code a game of tic-tac-toe with Python, and the tool produces starter code that you can refine. A popular example of this kind of application is ChatGPT, a chatbot created by OpenAI, an AI research company that partners closely with Microsoft. The key point is that generative AI isn't just automation. It's content creation, driven by language understanding. Generative AI applications are powered by large language models, or LLMs. These are specialized machine learning models designed for natural language processing tasks. That includes determining sentiment or classifying text more broadly, summarizing text, comparing multiple text sources for semantic similarities, and generating new natural language. Even though the math behind LLM can get complex, having a basic conceptual understanding of how they're built and used makes it easier to understand why copilots can be so helpful and why the way you ask questions has a direct impact on the quality of the output. Now let's connect those models to the cloud platform where many organizations deploy them. Azure OpenAI Service is Microsoft's cloud solution for deploying, customizing, and hosting large language models. It brings together OpenAI models and API with security, scalability, and governance you expect from Azure. Azure OpenAI services include pre-trained generative AI models, customization capabilities, built-in tool to detect and mitigate harmful use cases so you can implement AI responsibly. And enterprise-scale security like role-based access control, RBAC, and support for private network. And when it comes to development, you can build solutions using Azure AI Foundry, the REST API supported SDKs, or the Azure CLI. Azure OpenAI supports multiple use cases to serve different needs. GPT-4 models are the latest generation for natural language and code completion. GPT-3.5 models like GPT-3.5 Turbos are optimized for chat-based interaction and work well with many generative AI solutions. Embedding model converts text into numerical vectors, which helps with language analytic tasks like comparing text for similarities. And finally, we also have DALL-E models, which are used for image generation from natural language prompts. Developers can work with these models in Azure AI Studio, a web-based environment where you can deploy, test, and manage the models used for generative AI apps deployment. This is where you can experiment in Chat Playground, provide few-shot example, and validate that the model behavior matches what your application needs. The availability of large language model has led to a new category of computing, often referred to as copilots. Copilots are typically integrated in many existing applications and provide help with common tasks by tapping into generative AI models. You've probably seen this pattern already, where a chat panel opens next to your work and helps you draft, summarize, or create content using context from the product you're already in. It's also useful to think about the life cycle behind a copilot. First, huge amount of data are used to train a large language model. Then services like Azure OpenAI make those pre-trained models available, and developers can use them as is or fine-tune them with custom data. Once a model is deployed, it becomes available for applications. Developers then build Copilot experiences that submit prompts to the model and shape the output of real workflow. And finally, business users use those copilots to boost productivity and creativity, helping with first draft, synthesizing information, supporting planning, and so much more. Next, let's focus on something that directly affects your day-to-day success with any copilot: prompt engineering. Prompt engineering is the process of creating prompts to get better outcomes. And it isn't only for developers. Anyone using a generative AI application can improve responses quality by using clear language, setting expectation, providing examples, and grounding the request in relevant data. One technique is direct language, being explicit about the type of response you want. For example, create a list of 10 things to do in Edinburgh during August. Another technique is using system messages, where you describe how the assistant should ask, such as, "You're a helpful assistant that responds in a cheerful, friendly manner." You also provide example. Even though LLMs can respond with zero-shot learning, meaning without example, you can get more consistent result with one-shot or few-shot learning by giving it a sample response, like visit the castle in the morning before the cloud arrive, and letting the model continue with that style. Finally, grounding data gives the model context so that it can generate a more accurate output. For instance, if you want a summary of an email, include the email text in the prompt and ask the model to summarize it. Overall, the quality of a response depends not only on the model, but also how you communicate your goal and constraints. So clear, specific prompt makes a measurable difference. Let's quickly summarize what we've covered in this first module. Generative AI is typically built into software application and uses large language model trained on huge volumes of text to generate human-like natural language responses, and in some cases, even original images. You now have the essentials: what generative AI is, what large language model do, what Azure OpenAI is, what copilots are, and how prompt engineering helps you improve the response that you get. Now we'll shift from the AI foundation into the security-specific focus of this learning path, Microsoft Security Copilot. Here, we'll get acquainted with what it is, how it works, the terminology you'll see throughout the product, and what it takes to enable it in an organization. In this module, you'll get acquainted with Microsoft Security Copilot. We'll start with the basic terminology, then walk through how Security Copilot processes prompt, what makes a prompt effective, and how to enable the solution so users can begin working with it. By the end, you'll be able to describe what Microsoft Security Copilot is, explain key Security Copilot terminology, explain how it processes prompt requests, identify the element of an effective prompt, and describe how to enable Microsoft Security Copilot in your organization. Microsoft Security Copilot is an AI-powered cloud-based security analysis tool that helps analysts like us respond to threats quickly, process signal at machine speed, and assess risk exposed faster than may otherwise be possible. In other words, it's designed to help you move from raw security data to actionable understanding without losing time on manual synthesis. Security Copilot combines powerful large language model with security-specific models from Microsoft. It integrates Microsoft and non-Microsoft sources, and it learns at machine speed to help analysts identify and respond to emerging threats. Just as importantly, enterprise data is protected by comprehensive enterprise compliance and security controls, so you can apply AI assistance without compromising governance expectation. Now, let's take a look at the core use cases of Security Copilot. It's designed to make easy. One common scenario is incident summarization, using generative AI to distill complex alert into concise, actionable summaries. This helps you gain context quickly and communicate clearly across your organization, which can lead to faster response and better decision making. Another scenario is impact analysis, where AI-driven analytics helps you assess the potential impact of an incident. highlighting affected system and data so you can prioritize response efforts. A third scenario is reverse engineering of scripts. Instead of manually unpacking complex or obfuscated command line scripts, Copilot can translate the script into natural language and explain what actions are being performed, while also helping you extract and link indicators found in the script to entities in your environment. Finally, guided responses provide step-by-step recommendation for triage, investigation, containment, and remediation, often with deep links to help you take actions faster. Let's take a look at how you can experience Security Copilot. One way is through the standalone experience, available through a dedicated site. In this experience, you interact through the prompt bar, submitting requests in natural language, and Copilot returns output as text, image, or documents. It's also important to contrast this with the embedded experience, where Copilot's capabilities are placed directly inside Microsoft security products. We'll explore that next because embedded Copilot is often where analysis starts, right where the investigation is already happening. Some Microsoft product like Microsoft Defender XDR embeds Copilot directly into the user interface. In Defender XDR, areas such as incident and advanced hunting are examples of where the embedded Copilot can show up. The idea is simple. You don't have to leave the tool you're already in to start using AI-assisted summaries, guidance, or analysis. You start where you are, and Copilot helps you move faster. Before you start writing prompt, let's align on a few terms you'll see throughout Security Copilot. A session is a particular conversation within Copilot, and Copilot maintains context within that session. A prompt is a specific statement or question inside the session entered through the prompt bar. A capability is a function Copilot uses to solve part of a problem, and you may also hear capability referred to as skills. A plugin is a collection of capabilities provided by a particular resource like Microsoft Intune. And the orchestrator is Copilot's system for composing those capabilities together to answer your prompt. At the center of the experience is the prompt bar. You use it to tell Copilot what insights you want from your security data. Behind the scene, Copilot integrates with various sources through plugins, including Microsoft security products such as Microsoft Sentinel, Microsoft Defender XDR, Microsoft Intune, as well as non-Microsoft solution and open source intelligence feed. For each data source, the plugin brings a set of capabilities, each one designed to perform a specialized task within that product scope. Here's a concrete example. The plugin for Microsoft Defender XDR supports capability such as analyzing a file, generating an incident report, generating guided response, listing incident, and related alerts, as well as summarizing the security state of a device. When you ask a question, the orchestrator can choose and combine these capabilities so the response isn't just some generic text answer, it's grounded in your security tooling and data. Now let's make prompt writing practical. Security analysts and researchers should include 4 elements when writing an effective prompt: the goal, the context, the expectation, and the source. Your goal is the specific security-related information you need. Context explain why you need it or how you'll use it. Expectation defines the format or target audience, like whether you want bullet points, a short summary, or a report written for executives. And source is the known information data source or plugin Copilot should use. As you write prompt, keep a few things in mind. Be specific and concise. Iterate. Try alternative version of your prompt if the first response isn't quite what you need. Provide necessary context to narrow down where Copilot looks. Give positive instruction instead of focusing on what not to do, and directly address Copilot as you to make the request clear and actionable. Now let's walk through what it takes to enable Microsoft Security Copilot. To start using the service, organization onboard both the service and the user. Practically, you navigate to the Security Copilot site, choose an Azure subscription, and choose or create a secure resource group. Then you provision Copilot capacity by naming your capacity and adding at least one SCU, Security Compute Unit. After that, you set up the default environment and assign the appropriate role permission. Each of these steps is explored in more details next. Before anyone can begin using Copilot, administrators need to provision and allocate capacity. You must have an Azure subscription, and you must be an Azure owner, or at least an Azure contributor at the resource group level. One important nuance is that global administrators aren't automatically Azure owners or contributor by default. That access can be configured in the Azure portal. There are two ways to provision capacity. You can provision capacity within Security Copilot, which is the recommended approach, or you can provision capacity through the Azure portal. Once capacity is in place, Security Copilot also provides a usage monitoring dashboard for capacity owners, so you can track consumption and manage how capacity is allocated. After provisioning capacity, you set up the default environment. To do that, you'll need one of the following Microsoft Entra ID role: Global Administrator or Security Administrator. During setup, you're prompted to configure several settings, including how much SCU, Security Compute Unit, capacity to allocate, and the geographic location of your tenant, because customer data collected by the service is stored in that region. Security Copilot operates in Azure Data Center in multiple regions, including the European Union, United Kingdom, United States, Australia, New Zealand, Japan, Canada, South America. You can also decide whether to opt in or opt out of data sharing. Option for product improvements. For example, you can allow Microsoft to capture data from Security Copilot and validate product performance using human review, or allow capture and human review to help build and validate Microsoft Security AI model. Importantly, opting in doesn't allow Microsoft to use customer data to train foundational model. Another key setting controls whether Security Copilot can access data from your Microsoft 365 services. If this option is turned off, your organization can't use plugins that accesses Microsoft 365 services. And currently, this option is required for using the Microsoft Purview plugin. Changing it requires a user with a global administrator role. Now let's clarify permission. You can assign access using Microsoft Entra ID role or Security Copilot role. And a best practice is to use the least privileged role that still enables the work someone needs to do. Microsoft Entra role like Global Administrator, Security Administrator, Security Operator, and Security Reader apply beyond Copilot. So they grant broader permission across the tenant. To keep Copilot access more targeted, Security Copilot also introduces two roles that function like access groups, but are managed within Copilot itself: Copilot owner and Copilot contributor. These roles grant access only to Security Copilot features. The security administrator and global administrator roles in Microsoft Entra automatically inherit Copilot owner access. And by default, all user in the Entra tenant are given Copilot contributor access, meaning any user with a licensed tenant can create sessions and run prompt unless an admin restricts what access by removing all users from the workspace contributor assignment and replacing it with a specific security group. One more nuance: Copilot doesn't go beyond the access you've already have. Even if you can open Copilot and create prompt, individual plugins may require additional product-specific role. For example, to use Microsoft Sentinel plugin, you need a Sentinel role like reader to access incident in the workspace. To use the Intune plugin for devices and policy, you need an Intune specific role, such as an endpoint security manager. In many cases, Microsoft plugin uses an on behalf of model. Copilot recognizes licensing and signs into product on your behalf whether the plugin is enabled, while some plugin requires extra setup and parameter for authentication. Let's summarize this module. Microsoft Security Copilot is an AI-powered cloud-based security analysis tool designed to help organizations meet the growing challenge of cybersecurity. You'll learn what Security Copilot is, key terminology, how prompt requests are processed through plugins and capabilities, what makes a prompt effective, and the practical steps to enable Security Copilot, including capacity, environment setup, and the role permissions. Next, we'll focus on embedded experiences, where Security Copilot is accessible directly from Microsoft Security product. This matters because it brings AI assistant right into the investigator's workflow, reducing context switching and enabling faster decision. Microsoft Security Copilot is accessible directly through some Microsoft Security product, and that's what we mean by the embedded experience. In this module, we'll take a look at the scenario supported by the embedded experience in Microsoft Security Solution. By the end of this module, you'll be able to describe Microsoft Copilot in Microsoft Defender XDR, Microsoft Purview, and Microsoft Entra. Here, we bring the embedded concept into focus. Microsoft Security Copilot is accessible directly from some Microsoft Security products such as Defender XDR, Microsoft Entra, and Purview, with more integration coming. In the embedded experience, Copilot invokes product-specific capabilities directly, which can improve processing efficiency because the right tool and context are immediately available to Security Copilot. The embedded experience is also a great place to start a security investigation. And when you need a deeper cross-product investigation, you can seamlessly transition to the standalone experience to bring in all the Copilot capabilities enabled for your role. To use an embedded experience, the Microsoft plugin for that solution must be enabled, and the user must have permission to access Copilot, plus any additional permission required to access the underlying product and data. Let's take a look at a key example. Security Copilot embeds in Microsoft Defender XDR. This integration is designed to help security team investigate and respond to incidents quickly and efficiently. Within Defender XDR, Copilot can support capabilities such as summarizing events, providing guided responses, analyzing scripts, translating natural language into KQL queries for advanced hunting, generating incident reports, analyzing file, and summarizing devices. When you need to understand an incident fast, Copilot in Defender XDR can generate an incident summary. Copilot creates an overview of the attack that helps you quickly understand what happened, what assets are involved, and the timeline of the attack. In fact, Copilot automatically creates a summary when you navigate to an incident page. Incidents containing up to 100 alerts can be summarized into a single incident summary. Depending on the data available, that summary can include when the attack started, where it started, meaning the entity or asset involved, a timeline of how the attack unfolded, the assets involved, indicator of compromise, and even the name of threat actors involved. The value is immediate. You spend less time reading raw alert detail and more time making informed response decision. Another powerful capability is guided responses. Copilot in Defender XDR uses AI and machine learning to contextualize an incident and learn from previous investigation, generating appropriate response action you can follow. This helps incident response team at all levels apply response actions confidently and quickly. Guided response are organized into categories. Triage includes recommendation for classifying incidents as informational, true positive, false positive. Containment provides action to contain the incident. Investigation suggests next step to gather more evidence, and remediation focuses on response action applied to specific entities involved in the incident. Each guided response card includes details like why the action is recommended and may include options such as viewing similar incident, helping you learn from patterns across your environments. For remediation actions, team can also view user information when steps like password reset are required. Many sophisticated attacks, including ransomware, use script and PowerShell to evade detection. And those scripts are often obfuscated, making analysis slow and error-prone. Copilot script analysis capability in Defender XDR helps reduce that friction by letting you inspect script and code without relying on external tool. You can access script analysis from the alert timeline within an incident, specifically for timeline entries that includes a script or code, such as PowerShell.exe event. Copilot supports scripts languages like PowerShell, Batch, Bash. The outcome is faster understanding of what the script is doing and quicker determination of whether it's malicious or benign. Threat hunting often requires writing KQL queries, and that can be a barrier if you're new to the language or you're trying to move quickly. Copilot in Defender XDR includes a query assistant capability in advanced hunting that reduces the time it takes to write hunting queries from scratch. You can generate a KQL query from a suggested prompt, or you can enter your own prompt in natural language, like asking for all alerts involving a specific user. Copilot then generates the KQL query aligned to the advanced query schema. From there, you can run the query directly or insert it in the editor to refine it save it, share it, or run it later. This frees you to focus on investigating threats instead of wrestling with the syntax. Here we shift from investigation to documentation. In Microsoft Defender XDR, Copilot can generate a full incident report with just a single action. By selecting the ellipsis or the report icon, you can ask Copilot to generate an incident report that consolidates everything that happened during the incident lifecycle. That includes key timestamp for incident management actions, the analysts involved in the response, how the incident was classified, and the investigation and remediation action that were taken. It also captures follow-up action, recommendation, and next steps. While an incident summary gives you a fast overview of what happened, an incident report provides a comprehensive, auditable record that brings together analyst-driven steps, automated action, and supported context from across Defender XDR and Microsoft Sentinel. Let's take a look at how Copilot helps with file analysis. Sophisticated attacks often rely on files that closely mimic legitimate or system files to avoid detection. Copilot in Microsoft Defender XDR enables security team to quickly identify suspicious or malicious file without manually digging into raw details. When you analyze a file, Copilot produces an overview that assesses the file's behavior and risk level, along with a detailed section that includes things like embedded strings, API call, and relevant certificates. This allows analysts to move quickly from uncertainty to clarity and decide whether the file represents a real threat. Another valuable capability is device summarization. Copilot can generate a concise summary of a device security posture, including vulnerable software, exposure level, and any unusual behavior that have been observed. Security analysts can use this device summary to accelerate investigation by understanding the broader context of a device involved in an incident. Whether accessed directly from the incident assets view or from the device overview page, the summary helps team quickly determine whether a device represents a larger risk to the environment. Across all these Defender XDR features, there's a few capabilities that remain consistent. One is feedback. Just like the standalone experience, the embedded experience allows you to provide feedback on AI-generated responses, whether they look accurate, off-target, or potentially inappropriate. This feedback helps improve the overall quality and reliability of Copilot responses. Another shared capability is the ability to move from embedded experience into the standalone experience. The embedded Copilot is a great place to start an investigation, especially when you're already working inside Defender XDR. If your investigation expands and requires deeper cross-product analysis, you can seamlessly transition into the standalone experience and continue with the full set of Copilot capabilities enabled for your role. Now let's introduce another powerful extension of Copilot security, Copilot agents in Microsoft Defender. These agents are available through the security store in the Defender portal and are designed to help automate and accelerate common security operation tasks. In the Microsoft Defender portal, the security store offers a growing collection of agents published by Microsoft and partners. These agents integrate directly into Microsoft Defender and perform tasks such as incident triage, investigation, threat hunting, and threat intelligence. Each agent is purpose-built to reduce manual effort and helps SOC team operate more efficiently. By the end of this module, you'll be able to describe the Security Copilot AI agents available in Microsoft Defender and understand how they support real-world security operation workflow. Let's take a closer look at the agents currently available. To purchase and deploy custom agent from the security store, you need access to the Security Copilot workspace provision with SCU capability. The phishing triage agent helps security analysts automatically triage and classify user-submitted phishing incident. It operates autonomously and is triggered when a user reports phishing emails. The agent requires Microsoft Defender for Endpoint Plan 2 and Security Administrator permission to configure. The Threat Intelligence Briefing Agent provides regular customized threat intelligence briefing by gathering and synthesizing information from multiple sources. It runs autonomously and helps teams stay focused about relevant threat without manual research. The Threat Hunting Agents assist analysts with end-to-end threat hunting using natural language. It not only generates KQL queries, but also interprets results, surfaces insights, and guides analysts through a complete hunting session. Finally, the Dynamics Threat Detection Agent is an always-on backend service that continuously looks for hidden threats across Defender and Microsoft Sentinel. It uses AI to correlate alerts, events, anomaly, and threat intelligence to uncover false negative and detection gaps. Here we focus on the phishing triage agent in action. Once deployed, this agent automatically evaluates user-submitted phishing messages, analyzes indicators, and classifies the incident. By offloading routine phishing analysis to an autonomous agent, SOC team can reduce alert fatigue and focus their time on higher impact investigation. And now let's take a moment and see Security Copilot in action. Let's take a look at a demo together. In this demo, let's set up Microsoft Security Copilot. First thing we're going to have to do over here is grant an administrator the necessary privileges to manage the service itself. So we're going to set up permissions in Azure to do that. Let's get started. We're in the Azure portal right now. We're going to open up Entra ID, and in Entra ID, let's go down to Manage and turn on Access Management for Azure Resources. We're going to do that for Howard Avery. And we're done. Let's go back out of the Azure portal and let's select our subscription to ensure that Howard Avery now has the necessary permission, not just to manage Entra ID, but also to set up, configure Security Copilot. So from the subscription, we're going to click on Access Control, IAM, Identity and Access Management. And let's set up a role assignment. Let's add a role assignment. Which role? We're going to need a privilege administrator role for that one. So let's give Avery Howard the owner role. This is a very permissive role. So as always, if you can use a less permissive role, the better. Next, let's select who is part of that role. Normally, we would select a group, but for that demo, I'm going to select a user. Let's go with Avery Howard once again. And we're going to give Avery Howard full privilege with that role. Allow user to assign all role except privilege administrator. So we're just going to remove that privilege, but Avery Howard has every other administrative permission. available to him at this point. We're pretty much done. Now let's set up the capacity for Microsoft Security Copilot. We've already granted Avery Howard the necessary privileges to do so. Now, as Avery, let's start by selecting the Azure subscription we want to use, the resource group in where we want to provision the service. We'll give the capacity a name. We'll stick with the default. And where do you want to provision it? We're going to select United States for this demo. But if the region becomes busy, we are going to allow Copilot to spill into other regions as well. If this is not acceptable, if Copilot must stay within your region, whatever that might be, then don't select that option. Capacity region, US East is selected for us. And finally, how many units do we want to provision? Let's start with one. And this is something we can adjust after the fact. Finally, we can also turn on dynamic usage. So use coverage unit when needed. If we exceed our 1 unit capacity, we can now start using capacity on demand. $6 US per unit as we need them. This is something you can turn on or off at your leisure. And finally, when it comes to on-demand unit, do we want to cap it or do we want to let Copilot scale to whatever level is necessary? Let's accept and acknowledge that we understand the terms and condition and start provisioning the capacity. Do we want to send telemetry to Microsoft? I'll let you choose. Your information is never used to train the model. As is mentioned over here, we never ever use our client information to train our AI model. Finally, do you want to integrate Microsoft Purview in your Security Copilot? Might as well. And let's also grant access to our users that are part of security group, standard security group in Purview, Entra ID, and Azure to be able to use the Security Copilot as well. Let's turn on recommended Microsoft security roles. Let's continue. And we're set. We've provisioned Security Copilot, and now we're ready to start using it. We're going to take a look at the interactive experience. Then we'll also take a look at the embedded experience. Before we start using the interactive experience, we can see that Security Copilot gives us prompts for us to explore. Let's go to the hamburger button in the upper left corner. There's a number of goodies in here I'd like to explore with you before we get started. There's your home link. There's your session. Any conversation that you have with Security Copilot will be saved, and you can go back to them at any time. From here, we also have the prompt book library, which are pre-built prompts that you can use, and you can define your own prompt book to execute a sequence of prompt, a series of prompt, and we can parameterize our prompt books as well. We'll see an example later, but for now, let's go into our settings. These are our personal settings. Here's the number of secure compute unit we're using, the name, the capacity we set up earlier, our subscription, our resource group, and we can change those if necessary. We're not going to do that in this demo. There's our total compute unit. And again, we can change that if necessary. We can also turn on and off whether or not we want to send telemetry to Microsoft and whether or not we want Security Copilot to be integrated with Purview. Let's keep things as is. Finally, down below, who can upload files to Security Copilot? Right now, we've got no one can upload files. We'll leave it as is. Next, plugins. This is where you get a lot of your power out of Copilot. You can enable or disable a variety of plugins over here. Right now, we've only got accessing data from Microsoft 365 services. It's not turned on, but we can turn it on with a single click, and we're good to go. We can also control who can manage the plugins. For now, we'll leave it as owner only. Role assignment. Who has access to Security Copilot? Right now, we've got 3 role who has access to Security Copilot. We can add additional member or simply click on add recommended role, add a click. This will add everybody in Entra ID role, Purview role, and Defender role that deal with security. They will now have access to Security Copilot. Let's take a look at usage monitoring. This is important over here. You want to get the best value out of Copilot. So how used is the service based on the capacity that we provision? Who uses the service? We can see over here the users and how much they have made use of Security Copilot. And let's take a look in our settings. This is for our comfort and convenience, the theme we want to use, the workspace we're working against. Language, you want to work in French, English, whatever language you want. Here's our privacy statement. And again, I want to reaffirm that we do not use your information to improve our AI services. All right, let's go back to home and let's actually use Security Copilot. We've got a number of prompts we can try. Down below, there's the prompt box. This is where you can enter your natural language prompts, queries. It uses generative AI. It uses large language models. So there's no form or structure that you're expected to use in your prompt. Express yourself using natural language. And take a look at the predefined prompt to get ideas of the type of interaction, natural language interaction we can have with Security Copilot. For example, here's a prompt. What group is app name assigned to? What are the critical Sentinel incident right now? We can click on those. If we select, for example, what group is app name assigned to, app name would be a parameter. We would enter the name of the app we want to look at. All right, let's open up a prompt book. Let's see prompt books in action. Here, a prompt book is a collection of predefined prompt that will execute. They're usually parameterized. In this case, I would specify the name of an actor, and then every single prompt that we see in that prompt book would be executed. And we'll see an example of that later on. There's a number of prompt books. I highly encourage you to explore those. They're categorized by roles, like SOC analyst, IT administrator, data security administrator. This will filter your prompt books. And going back to sessions, this is very valuable if you are handling multiple cases at once. Don't put them all in the same conversation. Start new session. Let's open a previous session. Here's the conversation that we had with Security Copilot previously, where we asked, what are the last 3 failed login? And we can see the last 3 failed logins, starting with Gerhard over here, same user again, and same user again. 3 times the user failed to log in. And now we're going to ask, what are the UPNs for the failed login? And Copilot gives us a nice bulleted list of those user principal names. So use natural language, ask question, get it to generate a response for you. And from there, you can put those in a spreadsheet. You can ask Copilot to give you a table, to give you bullets, to give you whatever output you'd like to use. This has been an overview of the interactive experience of Security Copilot. Now, let's take a look at the embedded experience of Security Copilot. So we looked at the interactive Copilot experience. Now let's flip things around and take a look at the embedded experience, where now Copilot kicks in automatically when you're doing your investigation, when you're working in Defender. Let's take a look at an incident that we have over here. Human-operated ransomware attack was launched. That is concerning. Let's do a little bit of investigation. As we open the incident, notice on our right, Copilot comes in and immediately provides a nice summary of the incident. There it is. I'm not going to read through the whole thing, but very handy, including the attack story, as well as suggestion on how to triage it, what to do with our users, the entities that encountered compromise over here, like contact this user, classify this incident. For now, we'll just mark the incident as completed, and let's continue to use the embedded experience to see what Copilot can do for us. We're going to take a look at a specific alert, suspicious RDP session, and as we select the alert, once again, Copilot kicks in and provides a nice alert summary, including the concerning lateral movement we're seeing over here. Let's take a look at the alert in more detail. We're going to open up the alert page. We can see the process tree. We can see the device that was involved. Let's use Copilot to provide a summary of that device. Here we go. Let's expand it. And here's the summary that was provided to us by Copilot. We'll close it. We can do the same with the user account, Jonathan Wolcott. Let's summarize their information. And once again, there it is, coming straight from Copilot. Let's close that. And let's take a look at the process tree. See what triggered the alert. We'll expand it. Scroll down a little bit, and there's some PowerShell stuff going on over here. We can see that PowerShell executed a script. That kind of concerns me. That's an end user machine. Why would they be executing a PowerShell script? Here's the script that got executed. Now, if you know how to read PowerShell code, cool. If you don't know how to read PowerShell code, not a problem. Let's get Copilot to analyze the script for us. Here it is in plain English for us to review step by step what the script does. And what's beautiful over here is even if the script was obfuscated, Copilot would de-obfuscate it for us, explain to us what it does. If there's any concerning activities, here it is line by line, explained by Copilot. We can see the lines of the script, and we can also see the MITRE techniques that were used in the script, things like native API call, or below that, we've got a system information discovery. So I don't need to be able to read the script. Copilot does the heavy lifting for me. So me at my end, as a security operation analyst, I can now properly action and investigate that incident. Another thing Copilot can help us with is understand files, not just scripts, but files that might have been used in the attack. Let's take a look at that. Let's crack evidence and response open files. These are suspicious files on the user's machine, starting with Mimikatz. What the heck is Mimikatz? Well, let's crack it open and let's get Copilot to explain it to us. Let's click on the ellipsis. Put the file. and generating a file analysis. And Copilot tells us the file mimikatz.exe has been detected, and it is a malware. It is a tool that is used to circumvent security capture information. Copilot gives us that. So let's continue our investigation. Now, let's do a bit of KQL. Whether you're a KQL guru or you're entirely new, let's switch over to the interactive Security Copilot experience. And what we're going to do over here is we're going to ask Copilot to help us further with that investigation using conversational plain language over here. So instead of us having to figure everything out ourselves, let's use a prompt book to kickstart our investigation. We're going to use the Microsoft 365 Defender incident investigation. There's one parameter we need to provide, and that's the Defender incident ID. That was 185856, if I remember correctly. Submit. Now, Security Copilot in the interactive experience will pull up all the details that I need to investigate that incident. There it is. Lots of actionable detail, still parsing through it. Now, I'm seeing some really interesting stuff in here, stuff I want to make sure I keep an eye on. So I'll select the result and I'll pin them. So now they're available on the right side over here. I can pin evidence and information that's related to my investigation and share that evidence with my team as well, so we can work collaboratively to handle this incident. I'm not going to share it right now, but there's the share button for you. And finally, let's use Security Copilot to help us with our query, help us with KQL. KQL requires a bit of specialized knowledge to be able to write a query, and we are going to take a look at KQL later on in this course. But for now, let's get Copilot to help us generate a KQL query using natural language. There you go. Based on the incident, create a query to proactively hunt for the type of malware attack. Let's submit the prompt. And let's get Copilot to generate a query for us. Shouldn't take too long. And there we go. Here is the query that Copilot generated for us, fully documented. It may seem intimidating. If you want, ask Copilot to explain it to you further, line by line. But for now, let's try it out. Let's go to hunting, or let's just go to our logs. Drop in the query that was generated for us by Copilot and run it. And here's our result. So we're able to generate a sophisticated query without having to write a single line of KQL code. If you need further detail on the query, you need follow-up query, you need to understand or change the query, go back to the interactive Copilot experience and get Copilot to help you modify your query. Add to it, modify it, whatever you need to do. Now that we've seen the interactive and embedded experience of Security Copilot, we've seen how we can use generative AI in our workflow to help us action and understand events, alerts, incidents in Sentinel. Let's wrap up Learning Path 2. In this learning path, you explored how Microsoft Security Copilot is accessible directly from Microsoft Security product through embedded experiences. You learn how to describe Microsoft Security Copilot in Microsoft Defender XDR, Microsoft Purview, and Microsoft Entra, and how these integration helps security team investigate and respond to threats more efficiently. This concludes our session. There's many ways to continue your learning journey. We encourage you to watch other videos in this course or search out your next favorite topic on Microsoft Learn at aka.ms/learn.